今天，几乎每一个人都拥有了不止一部移动终端。不过，您是否知道，移动设备的飞速普及给无线网络带来了巨大的挑战？如今的无线网络不仅需要同时接入更多的无线客户端，而且每台移动客户端上几乎都运行了大量应用，并且很多还是带宽高消耗型的应用。这种情况我们就称之为无线应用的高密度接入。现在802.11ac 无线网络为我们提供了高速的连接，但是这是否能够满足高密度接入的需求呢？说归说，做归做，只有测试多客户端在真实部署环境中的性能，才能真正体现802.11ac 无线网络产品的系统容量。下面就让我们来看看思科无线网络测试实验室是怎样进行高密度接入时802.11ac 无线产品的性能和容量测试的。Now we see a lot of laptops and iPads here. It's a testing setup, and Wes introduced it for us.
So this is our high-density multi-client test setup. We have 100 real clients here. It's a mix of laptops and tablets, Windows and Apple. We're really trying to stress the access point with a realistic mix of clients. So let me go a little bit into the test details. So we have 100 real clients here. It's a mix of Apple laptops. We have the MacBook Air 2 Spatial Stream 11AC. We have MacBook Pro 3 Spatial Stream 11N. We have the MacBook Pro 3 Spatial Stream 11AC. We have Windows machines with the Broadcom 3 Spatial Stream chip, the Intel 7260 2 Spatial Stream chip. We also have Apple iPads 11N. And all these clients are spread around this room anywhere from 3 meters out to 15 meters, and they're spread randomly pretty much around the AP. And the placement is meant to mimic a real-world scenario where you're not going to have clients always facing the AP in this same direction and that kind of stuff. The AP is mounted on the ceiling like you would expect in a real deployment. And it's mounted right in the center of the clients. Now if I go through the controller configuration, so we're just using a Cisco 5508 running 76130.0. We have followed our best practices configurations. We have application visibility and control enabled. We have, we're just using a 2700 AP. And if we look, we've disabled some of the lower data rates. So on 5 gig, our lowest mandatory is 12 megabits a second. On 2.4 gigahertz, same thing, our lowest mandatory is 12 megabits a second. And we've really followed our best practice configurations to try to, we would recommend this configuration to a customer. So let me actually run the test so I can go through the results. So we're using Ixia Chariot here as our test tool, and we have one pair per client, so we have 100 pairs, and we're using the default high throughput TCP script. And as the test starts to run, we'll see that the throughput ramps up, and the test duration is 2 minutes because the more clients that you have, and we have a lot of clients, we have 100 clients. So we're running a 2-minute duration, and we'll see, as the test runs, that the fairness between clients is actually very good. So I can switch the graph to look at the distribution of throughput, and we see that each client is receiving its fair share of throughput, which is very important in a high-density multi-client scenario. Yes, the aggregate throughput is important. You want that to be high, but it's more important for each client to be able to receive some portion of the bandwidth. You don't want just one client who is hogging the entire bandwidth, and so no one else, has a good experience. So in this test, the throughput is great, Right now we're at 310 megabits a second and would expect that to go up as the test completes, and our fairness is excellent.
头一次看到这么多客户端在一起的高密度测试场景，记者也感到很好奇。让我们来看看思科的无线专家对于 802.11ac 技术是怎么看的吧。Comparing with 802.11n, what's the advantage of 11ac technology? And what's the advantage of Cisco's 11ac products?
So one of the most significant updates that 802.11ac brings is the ability to connect at higher data rates, which means now that the clients and access point can communicate using more packets per second. Now there are three main reasons for more packet per second in 11ac. First is the wider channels, second is the increased modulation, and third is the advanced aggregation. With 802.11ac, now the channel width has been doubled from 40 MHz to 80 MHz. The modulation has increased from 64 QAM to 256 QAM, and the aggregation has increased from 64 kilobytes all the way up to 1 megabyte. Comparing this to 11n, if an 802.11n AP had the capability to push around, say, 30,000 1500 byte-sized packets per second through the AP's data plane, with 802.11ac today, it can go all the way up to 75,000 plus packets. So now more packets per second means more load on the AP CPU. So we really have to keep up with the demands of the 802.11ac, and for that we had to go back to the drawing board and enhance our AP hardware.
With the introduction of the AP3700 and the AP2700, Cisco fundamentally retooled the AP data plane for 802.11ac. We optimized the data plane for high density and multi-client environments using a lightweight packet scheduler. We were able to do this because of our custom-built 802.11ac chipset, which utilizes a large amount of on-radio caching. So this means that the AP is able to handle a large amount of clients in an efficient manner to make sure that each client receives its fair share of the bandwidth.
Comparing with commercial chip, what's Cisco's advantage?
Cisco's custom-built 802.11ac access points offer many advantages over the typical off-the-shelf access point. The 4x4 architecture with 4 transmitters and 4 receivers and 3 spatial streams. This is an architecture that we've used going back to the AP3600, but we've updated for 802.11ac with client length 3.0, which allows the client to have the best possible connection. Then there's on-radio RAM and CPU on each radio. Your typical off-the-shelf architecture will utilize the host RAM and host CPU for all control plane and data plane functionality. The Cisco architecture distributes data plane functionality down to the radio where the resources are closest and are the fastest.
After 看完这样一场令人印象深刻的测试，相信您对什么是高密度接入有了直观的体验。802.11ac 技术为高密度接入提供了可能，但是思科在芯片和软件上的独特创新，更使得 802.11ac 技术真正得以发挥其潜能，让无线网络成为一条容量巨大的信息高速公路。